All right, so we're at the stage now where we need to start taking some data regarding the size of your container. Because remember what this whole project was basically about, building the smallest possible container to protect the egg. And so now we have to gather your information and use it to determine who has the smallest container and prove that the egg didn't work. So you can see all the different shapes that we have here, simulating what your design might be. You're gonna have to, what we do here, you're going to have to adapt to your particular container. So we're basically gonna check height, the maximum height and the minimum height of your container. So let's start with this football shape design right here. If this was the housing for your particular egg container, so the egg would be in here somehow, we need to get two pieces of math out of this, the maximum height and the minimum height. So if we look at this, when we're looking at the maximum height for this object, we're looking at it from this tip here to this tip here. So if I take my ruler and I look, and we want to try to be as accurate as we can, I'm looking at about 8.5 inches. So from here to here, I'm looking at about 8.5 as my maximum height. My minimum height, I'm actually going to turn it down this way, and we can't go from the ends here. The minimum height is, in this case, the top of this object right here. So if I'm looking at this object, I'm seeing something that is about 5.25 inches. So my two dimensions that I'm going to put in there were the, I forgot what I said now, the 8.5 and the 5.25. Those were the two measurements that we're going to use for a container like this. Look at the ball container. If yours happens to be a circular shape, you're using a tennis ball, whatever the case may be. Again, we need to go from the highest point here. And in this case, because it's cylindrical, you know, this dimension is going to be the same. But we're looking at basically 4 inches by, so if I took this measurement and I wanted to see where I was at, I could do it this way right here. And this would give me, the best height. In this case, I'm looking at 4 inches, okay? And it would be 4 the other way as well. All right, so that's a circular shape. You look at a container like this, maybe your shape resembles something like this. This one's a little bit tricky. If we're doing the maximum height on this container, you have to picture it from the two corners. Picture this as if, how can I get this as tall as possible by rotating it on one edge? So if I rotate this up like this, this just increased the height of this object. So the height of this object is from this corner to this corner. So when I take my measurement on this, then you might have to have somebody study this for you and put the other piece across there. I'm going to get it one dimension going this way. That's going to be the maximum height using this angle here, not like this. This just got taller as I flipped it up on the angle. So from here, it's going to be from this point to the point touching for the maximum height. For the minimum height, it's going to sit flat, and that's going to be coming from the very top of this object. And I could put some math there, and I could look at what I have, and that is about 3.25 inches for the minimum height. So two different ones on this one. The only thing tricky on this is you need to flip that up on the angle, okay? If we go to the next container, on this next container, same thing. We look at it and we say, well, this isn't the maximum height like this. We have to take this object and we have to picture it as if we're anchoring it at one point, and where would I get that highest point? When you reach that highest point, this is your maximum height. So coming from here, and again, maybe have somebody study this for you, but you can take something and you can put it across and see what that distance is for the maximum height. For the minimum height, it will just be the top of this edge as it sits flat. So again, you can lay something across it, you can put a ruler there, and you can take the math on something like this and see what we're looking at. And we're looking at about 2 3/4 inches, somewhere in there, okay? So you want to be as accurate as you can, because there will be a data sheet where you will log the information in, and that will be compared against others in your class. And we will write that down, make sure that you record that, write that down, and then that data will be distributed throughout all of our classes to see class winner and then overall engineering tech for the smallest design.